Welcome guys to CSES group. This lecture is for 2013 electrical engineering optional paper for UPSC CSE mains, and we are looking for the circuit theory problems. The question is determine the resistance between A and D. Please correct it. Here is the mistake. The question is to determine for the D. Okay, so A and D. Where is A? A is here and D is here, using delta Y substitution. Okay, so you have a Wheatstone bridge like structure, and from there you need to find out the resistance between terminal A and D. So let us first recall what is the delta Y substitution. So I have drawn here for your reference. If you are having a delta, it can always be replaced by its equivalent Y. Now how to replace it? If you are considering a resistance Ra, which is here between R3 and R1, then Ra can be written as R1 multiplied with R3 divided by R1 plus R2 plus R3. Okay, and similarly, if you are considering a resistance here between R1 and R2, then you can write that RB resistance like this, and for RC between R2 and R3 you can write RC like this equation. Now let us apply this delta Y to the given question. I am using the upper triangle of this figure. You can even apply for the lower triangle, you will end up with the same answer. Obviously I am using the upper triangle, so let us apply that. If you apply, RA is equals to 4 by 5 you will find, and RB will comes out as 2 by 5 and RC will come as 2 by 5. Okay, so these three resistances are with you. Now if you replace it by this Y in this figure, you will find the equivalent figure as this one. Okay, then you need to simplify it again. So it's very well clear from this figure that RB and this 2 ohm resistance are in series with each other. Hence you can simply add them. You will find it is 12 by 5. Okay, so this portion is done. Now go to the RC and the 1 ohm resistance are in series with each other. Hence add them. You will find it is 7 by 5. Okay, so next level simplified diagram will look like this. You have 12 by 5 and 7 by 5 parallel with each other. So you can again merge these two branches and you will find this comes as 84 by 95, and the simplified version is now looks like this. So 4 by 5 in series with 84 by 95. So simply add them and you will end up with the answer, which is 32 by 19. Okay, so this is one of the simplest question which you will find in CSE paper for circuit theory. Let's go to the next part. The next question is determine the current I using the ladder method. Now what is the ladder method? What you have to do is you need to divide the current in this form. Okay, so ladder by ladder, step by step you are moving forward and you are identifying the current. That's what they are asking for. So you have the network with you like this. You are having a 10-volt supply battery here, and then various resistances value are mentioned. So what I am doing here is I am first of all redrawing the circuit in this form such that it will be easy for me to calculate the current and to analyze the circuit. Okay, so what are the steps involved in this? If I redraw it, I am giving the nomenclature as the current which is flowing in the first branch or the initial branch is I3, then next step it is I2, then next step it is I1, and then the last step is I, which is required for us. Okay, so what you need to do is you need to first determine the I3, then you need to go for I2 calculation and so on. So let's see here. I have merged all the resistances such that I can get a final resistance which is in series with this 10-volt battery, and you can find out the overall current which is flowing in this circuit. Okay, that is the I3 current. So please look at here, 1 ohm and this 10 ohm are in series with each other. Whatever comes in parallel with 100, so that is written here. Whatever comes is in series with 2 ohm, so that is written here in this section. Again next it is parallel with 50 ohms, so that is here. whatever comes is in series with 1 ohm, that is here. Whatever comes is in parallel with 200, is in series with 1 ohm, and then so on. Okay, so up to here I am writing, and then again I will go for parallel combination of this 200 with this equivalent resistance plus the series value here. Okay, so if I simplify this term, I'll get 9.9 plus 2 in parallel with 50. Further simplification will yield 11.61. Okay, so this 11.61 is what? This 11.61 is the equivalent resistance up to this step. Let me redraw it, or okay, let us first remove all this marking, then it will be easy to understand. Fine. Okay, so this 11.61 resistance is for this network. Okay, so 11.61 is there, which is now in parallel with this 200 ohms. Whatever comes is in series with 2 ohms. Okay, so if you do this calculation which I have written here, you will end up with 12.97. So 12.97 is the overall resistance of the complete circuit. That means from here to here. Okay, and by that you can identify what is the current flowing because of this 10-volt battery in this circuit. So that comes as 0.77 amperes. Okay, then break it step by step as I explained you. So further breaking will yield I2. So I2 can be written as I3 multiplied with 200. Okay, because you are not interested in this branch, hence you have to take this value. Please recall the current divider rule, divided by the overall resistance of both the branches, that is 200 plus 11.61. Please look at here, guys. This is what the simplified diagram for which I am applying the current divider rule, and you will end up with I2 is equals to 0.727 amperes. Okay, now I2 is there. We will go for calculation of I1 and then calculation of I. Okay, so let's go to the next part. I2 is already identified. Now we are going for calculation of I1. So I1 is equals to I2 multiplied with 50. Why 50? Because this is the other branch which is associated with 11.9 divided by 50 plus 11.9. Okay, so these two branches are only associated with this, hence you need to consider only these two. You need not to consider I1 and this one. Okay, don't get confused, guys, here. So I1 comes as 0.587 amperes. Okay, now once you are having I1, you can very well identify what is the value of I. Okay, so I is equals to I1 multiplied with 100 divided by 100 plus 11. From where it is coming, look at this portion of this complete circuit. This is your I1, which is getting divided into two parts. One is going to 100 ohms, the other is going to 10 plus 1, 11 ohms. Hence we are applying the current divider rule, and by that you can find out the I value, which is equals to 0.528 amperes. Okay, so this is what the current which is flowing in the last step, or the branch where you are having 10 plus 1 ohm resistance. Okay, next question number 2a for 2013 is, consider the unbalanced Wheatstone bridge. The internal resistance of the galvanometer is 1 ohm. Okay, and the Thevenin theorem has to be used to determine the galvanometer current. Okay, so look at the circuit here. You're having one 10 volts battery which is connected to a Wheatstone bridge. Obviously this is an unbalanced Wheatstone bridge, and you are having one galvanometer whose internal resistance is given as 1 ohms. Using Thevenin's theorem, you need to determine the current which is flowing in this branch. So what we have to do is, first of all, we need to replace this galvanometer. So you need to replace this galvanometer by its internal resistance, which is given as 1 ohm. And since you have to use the Thevenin's theorem, For that you need to again remove this 1 ohm, because now you have to consider that as a load resistance. Okay, so if that is the case, the equivalent diagram after removing the 1 ohm, which is we are considering as a load resistance between the terminal A and B, guys, will look like this. Okay, so this is what the equivalent circuit. Now apply the Thevenin's theorem to the given circuit. Since these two branches, which branches? The one which is having 100 and 100, these two series resistances, the other 110 and 90, these two are in parallel with each other, the voltage will be same. Okay, so both the parallel branches will be having 10 volts. So you need to apply the voltage divider rule here to identify the voltage at point A and point B. So VA can be written as 100, this 100 multiplied with 10, the supply voltage, that is here, divided by 100 plus 100. Okay, so that comes as 1000 divided by 200, that is 5 volts. Similarly for the VB is 90, the voltage drop across this resistance, multiplied with the source voltage, that is this 10, divided by 110 plus 90, which comes as 4.5 volts. Then VAB can be considered as VA minus VB, which is 5 minus 4.5, that is 0.5 volts. Let us call that equation number 1. Then the RTH can be identified by short circuiting the, okay, let me remove this. Yeah, let me remove. Okay, so what we have to do is we have to short circuit this source voltage, and we have to keep this load terminal as open, and then we have to look into this load terminal to identify the equivalent Thevenin resistance. Okay, so if you see that circuit from these two terminals, your circuit will look like this. So how it is simplifying our task? Let us see, this 100 and 100 are in parallel with each other, so that's what I am writing here, and this 90 and 110 are parallel with each other. Okay, so which is here. Then the RTH comes out to be 99.5 ohms. Now in the next step we will be replacing this circuit by its Thevenin equivalent. Okay, so Thevenin equivalent circuit, TEC. Let's see that. So the Thevenin equivalent circuit for the given question is the Thevenin voltage, that is 0.5 volts, the RTH 99.5 ohms, and the load resistance, that is the resistance of galvanometer, that is 1 ohms. Now apply the simple KVL to this circuit and you will find that the current which is flowing in the given circuit is 0.5 divided by 100.5, which comes out to be 4.975 into 10 to the power minus 3. Okay, so 4.9 milliamperes is the current which is flowing in the galvanometer. Thank you guys, that's it for 2013. Please comment, and in the next series I'll be discussing about 2014 circuit theory questions.